Let's carry on from where we left off with our sheet metal example 1, and let's add some more flanges so we can fully define the location of the top. So now I want to do the same process by adding an edge flange, and I'm going to do this on the bottom. And again, I want to modify the profile, and this time I'm actually going to do something a little bit different. I am going to drag this over. I'm going to look at this normal too, but instead of dragging these inward, I'm going to go ahead and add some more lines to it. Then I'm going to use my trim tool using power trim and take out the middle. Then I want to add some dimensions. I'm going to make this flange 1 inch wide and 0.75 tall. And then I want to make sure that these two top edges are equal. And now I have a fully defined sketch. I'm going to drag my dialog box back over and say finish. And you notice that it's unable to create this edge flange. Now, it's unable to create it because we use two individual profiles. So what we have to do is actually create one of them as construction and say finish. So you see with this one, it was able to create it, but we still need to modify the properties in order to set it inside. So we'll select edge flange, we'll edit the feature, and we'll modify its parameters. We're going to use tangent to bend and use the offset option, 0.08, and make sure that that's set inward. Now we have the same thing. We have the flange set inward 0.08. We can mirror it. We're going to start by selecting the flange, going to features, and selecting mirror. We're going to use the right plane and say OK. Now from the tree, we're going to select edge flange, control select mirror to, and select the mirror option again. This time we're going to select the front plane. Let's take a look at our results. Now this bend is really close to the edge. I'm not sure that I want it that close to another bend. So I can go back into flange 3, go into its sketch, and I can edit the sketch. Now inside here, I'm going to simply grab this left endpoint and I'm going to drag it inward. I want to make sure that I leave an appropriate amount of distance, so I'm going to give it 1/2 inch. Now because we based everything off of that one sketch, it was able to push it inward 1/2 inch and create all the other mirrored versions quickly and easily. So even though we had to add a few extra features in here, a few extra mirrors, in order to get all 4 of these tabs, it was a quick and easy way to handle it. Now we can go back and do things like add holes to it. Now from our sheet metal tab, you'll notice that we have simple hole option. But if we stay on our feature tab, we actually have the hole wizard. So I'm going to start by using hole wizard on one of these top flanges. The type of hole I want to select depends on what exactly I want to do. Now Solidworks is pretty good about giving you a lot of options. For instance, under the standards, I actually have a section for PEM. Now, if you've done sheet metal work or you're familiar with sheet metal work, then you understand what a PEM insert is. Basically allows you to use a specialized type of sheet metal fastener. And in SOLIDWORKS 2015, they added this, but in 2016, you can make sure that you use the PEM inch or PEM metric options. You don't have to look through a big list of hole sizes depending on what you want to do. In this case, let's say that we want to go ahead and use a blind fastener. We can filter. Let's say that we're going to be using a nut type fastener. Let's say that the hole size that we're going to be using is 1032. It automatically knows what size it's going to be. And instead of through all, I'm going to say up to next because I don't want to punch a hole all the way through the part. Feature scope, we're going to leave as selected bodies. We're going to go to the positions tab and select this face. I'm going to use Control 8 to look at it normal to, and I'm going to place a hole. Now I want to add a few relations. I'm going to start by drawing a line that's for construction. And I'm going to take this line from this midpoint and drag it over to that hole, double click. I'm going to go up to this midpoint and drag it down to this midpoint and double click. That allows me to go ahead and place this at the midpoint of this line, but also making sure that it is centered just in case we made a mistake when we originally made that flange. So now we've got the hole for the PEM insert directly in this top flange. Now, once we say OK, you see it says cannot create an extrude feature with a negative or 0 depth. Well, it's not actually creating a negative or 0 depth, but let's go ahead and modify this anyways. End condition, when we say up to next, it's not actually going up to next. We do have some options though. Near countersink, once we say OK, you see it still cannot extrude a 0 depth. Now, sometimes you're going to get these problems when you're using different types of hole wizard features. And the reason this happens is because a hole wizard feature is creating a plane and it's doing a revolve cut for these fasteners in most cases. What we want to do is we want to look through our options and figure out where the problem is. Let's try a smaller hole, an 832. It still cannot create it. But if I go down to my options, instead of doing up to next, if I say up to surface, it allows me to do things like select another face, and then it'll create the cut. So every once in a while, depending on the type of sheet metal part you have or the type of feature, you might have to play with some of the options in order to get the cut. Now, let's say that we made this hole, and instead of actually doing it again over here, we want to mirror it. Well, let's go back to this edge flange 1. You notice that mirror 1 is where we pushed it over to the other side. So I'm simply going to hold down the left mouse button on the hole wizard feature, drag it up just below edge flange 1. Then I want to left click on mirror 1 and edit that feature. In the features to mirror, I want to select the hole as well and say OK. So by simply reordering how things happened in our feature tree, basically the history, the order of operations, we were able to include that in the mirror. We're going to follow the same process for adding the hole down here as well. So again, we're going to go to Hole Wizard, and by default, it should have kept the last values that we created. So we're going to select a location by putting a hole on this face. Now, you will note that we won't be able to use the through all option here because we're putting a small countersink on the outer edge, which means if we did a through all, it wouldn't countersink that edge. But we do want to still make sure that we locate this appropriately. We're going to do for construction, and again, I'm going to add those construction lines at the midpoint of my flange. The reason I like to do this and add these at the midpoint of my flanges is because it gives me a nice reference that I can be 100% certain stays no matter how I modify this flange. If I make it bigger or smaller, I know that these reference lines are always there pointing me to the midpoint. You can do that without adding the construction lines, but sometimes it's a good idea to have those visual references, especially when you're just starting to learn. Now, you might also be wondering why I did up to surface option instead of doing something like a blind and giving it a manual distance. Whenever you're making a parametric CAD file, it's a good idea to use these sort of options like up to next, link to thickness, things of that nature, so that way when your designs change, you know that it's flexible enough. For instance, if I punched in the manual value 0.08 to cut that hole through my part, and let's say that somewhere down the line I decided to change the thickness to be 0.1, everything else would update, the flanges would update, but the manual offset of this flange downward and this flange inward would not update. So we really need to understand that when we're making these parametric files, we need to know exactly what is going to update and what's not going to update. And now you'll notice that as I drag this up, it's not allowing me to drag it up above mirror 2. And the reason that we can't do that is because in the end condition, I used up to surface, and I made this up to surface reference for something that's not physically there before that mirror happens. A good way around it is to say up to vertex and simply give it a point, for instance, on the end of this face. So now I know that this point on the edge of this flange was there before this flange was even created. So now I can drag that hole and I can include it inside of those mirror features. So inside of edge flange 3, I want to include that hole, and notice that it's automatically mirrored in the second set because all I did was mirror the mirrored feature. So now we have holes in the top and holes in the side. Let's go back and show our other solid body. And just to make things a little bit easier, let's make it transparent. So now you can see we have a flange on the top on both sides, and we have 4 flanges on the bottom. This should be more than enough to restrain our part. Now the next thing we really need to do is add some more fastener holes to make sure that we can bolt the top down to this part. But I think that's a good place to stop this video, so make sure we do a save as, add the number 2 after our example, and that way we ensure that we have the original file before we added the flanges, and the second file where we added the flanges and the PEM insert holes.